So friends, finally, let's look at that for organic chemistry, and this is going to be the last section of this particular year. So it rates that 2.648 grams of an organic compound has composition of we have 0.80 grams of carbon, 0.198 grams of hydrogen, then we have 0.47 grams of nitrogen and 1.18 grams of chlorine. If the molar mass of the compound was found to be 79.5 grams per mole, we should calculate the empirical formula and hence the molecular formula of the compound. Okay, so guys, let's start. So let's simply display the various atoms or elements that make up that organic compound. We have carbon, which has a mass of 0.80 grams. We have hydrogen, which has a mass of 0.198 grams. We have nitrogen, which has a mass of 0.47 grams. Chlorine, whose mass is 1.18 grams. Wait. So guys, I think these are the elements, right? These are the various elements that make up this. These are the various elements that make up this particular organic compound. Okay. Now, friends, the first thing you need to start by doing is to sum up all these masses to see if they will give you the original mass of the compound. If you sum up all of these guys, you see that the total mass is going to be 2.648 grams. Great. So we are good to go now. We can start doing the analogy. So what we are going to start by doing now, friends, is simply to divide these our masses by their respective atomic masses. The atomic mass of carbon is 12, so we are going to divide 0.80 by 12. That of hydrogen is 1, so we are going to divide 0.198 by 1. That of nitrogen, guys, is 14, so we are going to divide 0.47 by 14. Chlorine is 35.5, so we are going to divide 1.18 by 35.5. If we do that, we have that for carbon being equal to 0.0667 to 4 decimal place. That of hydrogen to be still be 0.198. That of nitrogen, guys, is going to be 0.0336. That of chlorine becomes 0.0332. So guys, this is simply their mole ratio. Okay, these figures are called their mole ratio because we are taking, keep in mind that moles is given as given mass for molar mass. The molar masses have been divided by their given mass, so this is what we have. So if you divide at this point now, guys, to get the empirical formula, guys, we have to divide all of these figures now by the smallest, which in this case is 0.0332. But if we divide that for the first, guys, we have an answer of about that of carbon to be 2. Then for instance, doing that of hydrogen, we are going to have 6. That for nitrogen, we are going to have about 1. Chlorine, guys, we have it to be 1. Therefore means that the empirical formula of this our organic compound becomes C2H6N1Cl1. So we're just going to have NCl. Great. So guys, this is our empirical formula. Great. But the question wants us to get the molecular formula, right? We have to proceed now on getting the molecular formula of this particular compound. Okay. Now guys, let's note very well that the molecular formula of the compound is simply given as the empirical formula, guys, times some constant, which can call that N. Great. Okay. So in this particular case now, we need to know that the molar mass of our empirical formula, guys, has to be given as, this is the empirical formula, the mass of carbon is 12, so we are going to take 2 times 12 gives us 24, plus hydrogen is 1, so we are going to have 6. Nitrogen, for instance, is 14, so we have 14. Chlorine is 35.5, so we have 35.5. Summing that, guys, gives us 79.5. Then it ever means that, guys, our 79.5 times this our small value n has to be equal to what the total relative molecular mass or the molar mass of the compound provided. So solving for n, guys, give us our n to be 1. It therefore means that our molecular formula, guys, has to be equal to the empirical formula, which has to be equal to just C2H6NCl. So this is the molecular formula, which is equal to the empirical formula in this particular case. Okay. Now that's it. The next part is saying I should briefly describe how the presence of the following elements can be confirmed in an organic compound after the sodium fission test. Alright, so many profiles don't know what is meant by the sodium fission test, so I will try to describe it briefly. Okay, So guys, we are going to drop the piece of sodium metal in a dry Pyrex test tube, and we heat the solution until the sodium red hots and melts. Then the test tube is then dropped into a piece of cold water. Great. So guys, this is simply the procedure. After it must have dropped into the cold water, guys, the test tube is going to shatter, okay? Because when we take a very hot Pyrex test tube, of which the sodium metal in it has been heated until it red hot, then melts. When you drop it into a beaker of cold water, the first thing the test tube does is that it shatters. Okay. So now, guys, the ions that are going to be present now are going to be uh, the if the organic compound or the compound, guys, had sodium, right, it's going to be converted into into so many forms, right? If it contains chlorine, it's going to be converted into sodium chloride and so on, guys. Okay, so that's where we are now. So friends, in this case now, chlorine and nitrogen, friends, will be converted into sodium chloride, and nitrogen will be converted to sodium cyanide. Okay, so let's talk about the case. So we are going to filter portions, and for the case of chlorine, guys, we are going to add nitric acid followed by silver nitrate. The nitric acid, guys, friends, is simply to simply neutralize any impurity present. Okay, we want to neutralize the impurity such that when we add silver nitrate, guys, know that silver nitrate is being used to test for the halide ions, right? So if chlorine was present, guys, we are going to see a white precipitate, which indicates the presence of the chloride ions. Great. Then now, guys, for the presence of for the case of nitrogen, friends, what we are going to do is that, friends, we are going to start by adding iron sulfate in the solution. Note that the resultant solution form, guys, is going to be it's going to be alkaline in nature. So adding iron sulfate means that the ion from the iron sulfate now reacts with the base to give us iron hydroxide, and upon adding FeCl3, guys, what we are going to see now, friends, is simply going to be a deep blue precipitate, which indicates the presence of the cyanide ions, and hence cyanide contains nitrogen, right? And hence we have tests for the presence of nitrogen. Okay. Then now the next part is saying that state the spectroscopic method which is suitable for the identification of the following aspects in organic chemistry. A multiple bonds. Okay, so guys, the multiple bond, we are going to use the infrared spectroscopy. Oops, guys, please replace this IC with Y. Okay, infrared spectroscopy. Then the Roman 2, we have the position of hydrogen. It is simply going to be, friends, the nuclear magnetic resonance method. That's the method in which we are going to use to identify the position of hydrogen. Okay. The D part talks about write out structures of two optically active isomers of this formula. Okay. So guys, this formula obviously is optically active because it contains a chiral center or a chiral carbon atom. So this is how the structure is going to look like. We have this carbon atom, wherefore the laser is on this particular one like this. Then friends, this way we have this our methyl group. Then the other way, guys, we have the carboxylic acid group. Then we have used that all what is left now is simply H and OH, right? So friends, in this case, the OH can simply go at the top, then the H can simply come down. That is where there is no rotation. This is it. So to get the other one, guys, this is a mirror line. We simply have to reflect this our isomer along this our mirror. When we do that, we are going to see that everything is going to remain the same except those at the sides. What has to be here now will be this one that is beside here, but the ones that are up and down, friends, remains the same. Okay, because there is no free rotation around this or around the vertical direction. Okay, so guys, that's it for this particular section. That's it. If there's something you don't understand, friends, the comment section is free, guys. Please visit the comment section of this video, and in the comment section, guys, you're going to find the link to watch all our playlists, guys, all which consists of inorganic, physical, and all other years as well, even hints. So make sure you watch it, guys. Let's go to the next question, guys. Let's go. We don't have time. Okay, the next part is that you are given the following compounds. We have this, this, and that. They said use the organic compounds above to write suitable equations that will illustrate the following types of organic reactions and name the major products. All right. So guys, let's start with the first electrophilic addition reaction. So guys, which of these compounds do you think can undergo electrophilic addition? Note that an electrophile in this case, guys, is simply an electron-loving species that is always going to migrate and go wherever there is an electron-rich center. So in this case, guys, the best one for us to use is the first. Okay, we have propene. In this case, there are a lot of pi electrons which can use. So we have this propene. Then our reagent is going to be bromine. Okay, so that's going to be it. So guys, this is what we are going to have. So guys, leave in the comment section below, guys, the name of this particular compound. I won't name any of them, guys. I will leave it to you guys to name them. If your answer is correct, guys, I'm going to give you a big heart for that, a big thanks and a big love. Then if your answer is not correct, friends, I'm going to tell you the correct answer even before the exam starts. Okay. Then now the next one is electrophilic substitution reaction. And the best one that can work for that, guys, is simply the benzene compound. So this is going to be it. So guys, I've chosen to draw the structure of benzene, okay, because most examination questions are going to be asking you, will be dealing both with the structure, not with the formula itself, okay, but with the structure. So please permit me to use the structure. Okay. So we are going to use the chlorination of benzene, the halogenation of benzene, okay, with chlorine. So we are going to have this. We are going to have chlorobenzene, okay. But for instance, this is only going to happen whenever there is an electron carrier, okay. So we are going to use FeCl3 in this case, although they didn't ask us for the reaction conditions, but it was necessary for me to involve this. Okay, that's it. Then now the next one talks about nucleophilic substitution reaction. So what we are going to use now, friends, is simply going to be this other compound. This, okay. So which simply reacts with the cyanide, which simply reacts with the cyanoion, guys. And in the case, guys, bromine is being taken out. So in this case, guys, you discover that I have written just our product, right? Which is going to be this, our compound, when bromine has given way for the cyanoion. So I have excluded bromine because in organic chemistry, friends, in most cases, you don't need to write the complete reaction. You just need to write only what is necessary for your reaction, only your product of interest. That is all what you need to write. Okay. So this is what we have. Okay. Okay. So that's it, guys. The Roman 2 wants us to write reactions for the nitration of benzene, and we should give the mechanism. All right. So guys, this is our for the nitration of benzene, guys. We have to show them where we are getting the nitrating mixture, and it's from the reaction of concentrated sulfuric acid plus concentrated nitric acid, which is going to generate the nitrating mixture. Like I said, guys, this is not the only product generated, but this is our major product of concern. So we don't care about all the other products. We care just about what we need. Okay. Now let's have our benzene plus the nitrogen mixture, guys. Simply gives us nitrobenzene. Okay. And that's it. This is nitrobenzene. So friends, make sure you name these compounds. Okay. Name this compound and this. Okay. Make sure you name them. I'm waiting for your answers in the comment section down below, guys, if there's something you don't understand. So this is it. Let's not draw the mechanism, guys. So for the mechanism, friends, let's look at the mechanism. We have our benzene compound plus this is the nitrogen mixture, guys. This is going to give us what happens now is that this our pi electrons now is coming to attack this positive our nucleophile, okay. This our electrophile, sorry, it is coming to attack it. Note that in practice, guys, the arrow needs to leave from where they are dense electrons now to where they are limited electrons, because electrons are the ones that move, okay. Protons are not moving, so electrons are the ones that move. So at the end of the day now, guys, you notice that the ring is going to be distorted. There's going to be some positive charge on the ring as the NO2 or as the NO2 minus and the H plus now are competing to see which one stays. Eventually the hydrogen atom has to give way for the NO2 plus. At the end now, guys, we simply have our nitrobenzene. As you can see here, guys, plus what comes out is our H plus, which comes out. Okay. So guys, that's it. That's it. Or that's the mechanism for the reaction, guys. So guys, that's it. Let's go to the next question, guys. Let's go. We don't have time. Let's go. The next question is based on synthetic route. It's saying that consider the reaction sequence below. Okay, this is it. It said give the reagent and reaction conditions for the processes below. Okay, so let's look at this first step. Our Roman 1, guys, has to be to convert from nitrobenzene, guys, to phenylamine. It to phenylamine, guys, we need to use our tin and concentrated HCl. And the reaction condition, guys, is that we are going to reflux the reaction. Why refluxing it, guys? Because phenylamine, guys, is highly volatile. If we don't reflux it, guys, the moment this reaction goes to completion, guys, we won't have any product because this guy must have evaporated to the atmosphere. Okay, it must have evaporated. So we need to reflux it. That's the reaction condition. Then for the next one, guys, for Roman 2, guys, we simply need water, because what is going to be produced here in this C, guys, is going to be benzene diazonium salt. Okay, and to get this our compound, which is phenol from it, we simply have to boil it with water at a temperature that is greater than 10 degrees Celsius. So the reagent is water. Reaction condition is what? At a temperature T greater than 10 degrees Celsius. Now for Roman 3, guys, you know that Roman 3 is simply kind of reaction. So the reagent in this case, guys, we are going to use copper cyanide. That's potassium cyanide. Sorry, copper cyanide, guys, can also work. Okay, or just a Cn minus ion. Okay, because that is what actually affects the change, and we have to heat it. That's the reaction condition. Reagent is potassium cyanide. Condition is that we have to heat the mixture, and we are going to have this. Then now, friends, for Roman 4, you see that Roman 4 can be any substance, okay, any substance, as far as it can give us a product, because F was not actually specified. So in this case, I want to leave from this cyano group now into benzoic acid. So I'm going to use my dilute H2SO4. I can use HCl, guys. It's going to solve the task for me. Then I have to boil that, or I have to put a temperature of 100 degrees Celsius. Wait, that will solve the task. Okay, that's it, guys. The next part is saying that we should give the formulas and name of the compounds C and F. C and F. So guys, I'll always be giving you guys exercises, okay? You guys will answer that, but maybe I'll tell you by mouth, or then maybe we should try to sort it out to see if it works. So guys, compound C, guys, is what I mentioned it earlier, right? For those of you guys that paid attention, you should go to backward the video and see the name. But F, I also told you guys, in fact, I've told you guys almost everything. So just write down again if you're able to recall all what I told you, the names of compound C and F. Yeah. Now, what I want you guys to do now is to write down the formula in the comment section below. I look forward to review them. Make sure you write the formulas, guys. Okay. Let's go to the next question, guys. It's saying that we should consider the organic compounds. We have this, that we should describe methods in which can distinguish chemically between the compounds A and B. Okay. So, guys, A is phenol, right? Then B is we have C6H5CH2OH. So this is we have let's see, this is a phenyl group, then this is methanol, right? Okay. So guys, to distinguish between the two of them, guys, the best way for us to do is to pick one of them. Let's take phenol. How can we test for phenol, guys? What we are going to do is that for A and B now, friends, we are going to use neutral ion trichloride. Okay, you know the question did not say we should describe, right? The questions want us to distinguish them. So reagent reaction conditions and the expected observation, guys, is the best method to go about this same question. So the reagent And the reagent in this case is going to be using neutral iron trichloride, and the reaction condition is that it's going to occur at room temperature. What do we expect to see, guys? We expect to see a violet coloration with phenol, but not for benzyl alcohol. Okay, not for benzene alcohol, not for this, or not for not for benzol, right? Not for this compound. So we expect to see a violet coloration with phenol and not for this compound. That's how we can test them. So whenever we see a violet coloration with purple coloration, sometimes we simply know that that what is present is what, guys? Phenol. Okay. Then the next, we distinguish between D and E. D is an alkene, that is propene. E, what, guys? E is propyne. Wait. And the best way for us to do that, note that they both of them will decolorize bromine water. Okay, they both will decolorize bromine water in the dark. So what we have to do now is to use the terminal alkyne test. And for terminal alkyne, guys, we are going to use ammoniacal silver nitrate. Namely, guys, for D and E, guys, you're going to use ammoniacal silver nitrate, that is this compound, at room temperature. What is our observation, guys? We're going to see white precipitate in the test tube that has CH join, C triple bond CH, but not for this compound. Namely, in the terminal alkyne, we see a white precipitate, but for alkene, we will not see it. Wait, that's it. Then for A and C, guys, A is phenol. C is what, guys? C is benzoic acid. Note, guys, note that the both of them have OH group, right? So they are going to like cause some white misty fumes when reacted with PCl5. But in this case, guys, we are going to go for this guy. We're going to go for this. You could decide to still use the first method of testing in this case, okay? The first method of testing by using violet coloration is going to give you that. That's going to be good. But let's use something different. Let's use sodium carbonate. So for A and C, guys, you're going to use sodium carbonate at room temperature. What I'm going to see is a colorless, odorless gas that turns blue litmus paper red. In the test tube that has the benzoic acid, no observable change for the test tube that has phenol. Great. So the colorless, odorless gas, friends, that turns blue litmus paper red, or in place of this, guys, you can say that it turns lime water milky. Great, guys, you guys got it. It's what, guys? It is no other gas compared to carbon dioxide, right? So it's carbon dioxide. So that's it. The next part is talking about what's a zwitterion. So friends, a zwitterion is simply a polar form of an amino acid which occurs whenever an H plus ion is transferred from the carboxylic acid functional group into the amino acid functional group. Right? That's a zwitterion. They want us to write the structure of alanine, this in neutral medium. That is the zwitterion form of this. As the definition suggests, guys, you're going to remove this our H from this carboxylic acid functional group and put it where we have the amino functional group. So if you do that, we are going to have NH3 plus, then we have COO minus. This is how it exists in neutral medium. They want us to state the physical method by which the mixture of zwitterion can be separated. So guys, we are going to use chromatographic method or liquid chromatography. That's the method. Then the next part is saying that CH2, that's this we have this our compound, that's an aldehyde, right? Then this ketone reacts with 2,4-dinitrophenyl hydrazine to give an orange precipitate. What's the general name given to this type of reaction? So guys, this is a condensation reaction because a molecule of water is being liberated at the end of this process. Okay, so it's a condensation reaction. You can give other type of reactions that will suit it, but in this case, guys, it's condensation reaction. The reason is that molecules of a water molecule is being liberated from this reaction. They want us to write an equation for the reaction between 2,4-dinitrophenyl hydrazine and propanone. Great. Okay, let's dive in. So guys, this is the structure of 2,4-dinitrophenyl hydrazine. This is the compound itself. When it's with propanone, guys, keep in mind that what actually gets targeted is simply what, guys? Is simply this oxygen in between this guy goes and these two hydrogen at the edge. So at the end of the day, guys, we are going to have something that looks like this. We are going to have this. Good, guys, this is what actually happens. The oxygen goes and everything stays the same. So this is what we are going to have, guys. This is it. This is what we are going to have. That's it, guys. That's it. Okay, let's look at the next question. Let's look at the next. The next one, they are saying that we should state suitable reagents and reaction conditions, or we should state the condition for this reaction to take place. Okay, so guys, this reaction can only take place in the presence of methanol and sulfuric acid. There is a special name given to the combination of methanol and sulfuric acid, guys. I'll leave it to you guys. Tell me the special name in the comment section down below. If you're correct, guys, I'll give you a heart for that. The next part wants us to state the reagents and reaction conditions for the following conversions to leave from this to this. Okay, from we have bromoethane to uh to this our compound. Oh my god, you have 1 2 3, so it's propan it's propan. Then we have this to this. Note that, okay, let's start with the first. So friends, to leave from that to that, the reagent we are going to use is alcoholic cyanoion. In the condition is that we have to heat the mixture to enhance that. Okay, we have to heat. So that's it. Then for the next case, guys, this simply was the case of Hoffman's degradation, in which the total number of carbon atoms reduces by 1, right? So we have to use Hoffman's degradation. And the reaction condition, guys, we have potassium hydroxide and bromine. And guys, the condition is that we must warm that mixture. In place of warming, guys, you can simply put reflux. Okay, we have to reflux it because the amine group, guys, is highly volatile and can escape into the surrounding upon preparation. So guys, that's it for this video. That's it. If there's something you don't understand, friends, the comment section is free, guys. Always get to me via the comment section, guys. Good luck as you prep for your exam, guys. You need to have A grade because the academy is an academy of A grade. Make sure you share this video with your friends, guys. Share it all with them. Help them to pass the exams well, and have a blessed day.